Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 35 by integration, find the moment of inertia about A, the x-axis, and B, the y-axis. So here is the given figure. We have a region bounded by cosine curve 12, y is 12 cosine pi x over 40. So for our solution, let's have vertical strip, and the height is y, thickness is dx, and the distance of the strip from the y-axis is x. So with respect to the x-axis, our differential ix is by experience 1/3 y cubed dx. Then we multiply it by 2 because we have two symmetrical region about the y-axis. So, or above the x-axis. So we have 2 1/3 y cubed dx, where y is equal to this. So differential ix is 2/3 of quantity 12 cosine of quantity pi x over 40 dx. So ix is 1152 integral from 0 to 20 of cosine cube of quantity pi x over 40 dx. So we will let u be pi x over 40, and the differential is pi dx over 40. So that this is in the form integral of cosine cube of u times, uh, we make this pi over 40 dx and put the reciprocal of pi over 40 before the integral sign combined with 1152. Now, we also change the limits. So when x is 0, u is pi times 0 over 40, so u is also 0. When x is 20, pi times 20 over 40 is pi over 2. So the upper limit would be pi over 2. So ix equals 1152 times 40 over pi, quantity from integral from 0 to pi over 2 cosine cube of pi x over 40 times pi over 40 dx. So again, we imagine that this is in the form cosine cube of u du. And we can apply Wallay formula here because the limits are from 0 to pi over 2. Now, for the sine function, it is non-existent here, but the rule by that Wallay formula from integral calculus is we just replace it by 1. For the cosine, the power is 3, so it is power of cosine minus 1. Then until we decrease it by 2 until it is 1 or 2. Because 3 minus 1 is already 2, so we stop at 2. Then there is alpha, which is equal to pi over 2, which is equal to 1 here because uh, the exponent of cosine is 3 and the exponent of sine is 0, which is not non-existent here, but they are not even, both even. So if the exponents are both even, then that's the only way alpha is pi over 2. But in this case, alpha is 1. Then the denominator is the sum of the exponents, which is 3, decreased by 2. So the next is 1. We stop at 1. So Ix is equal to 46080 pi over pi. This is for the sine, which is 1 by rule. This is for 3 minus 1. Then we stop at 2. This is for alpha, which is 1 because neither exponent of m nor exponent of sine nor exponent of cosine are even, so that's why it's 1. Then here it is the sum of exponent, which is 3, decreased by 2, so the next entry is 1, then we stop at 1. So simplifying this result, Ix is equal to 3720 over pi, or that's approximately 9,778 inches to the fourth. And with respect to the y-axis, it is differential Iy 2 times x squared differential area, where differential area is y dx. So differential Iy is 2 times x squared times y dx. Then the variable of integration is again x, so we replace y by 12 cosine of pi x over 40. Differential Iy is 2 times x squared times quantity 12 cosine of pi x over 40 dx. So simplifying and integrating, Iy is 24 integral 0 to 20 of x squared cosine of pi x over 40 dx. So the integrand is a product of algebraic function and trigonometric function. So this can be uh, evaluated patiently by integration by parts. So you put u be x squared, du is 2x dx, then dv is cosine pi x over 40 dx, then you expand uv minus integral of v du. It will again involve uh, algebraic x and trigonometric function, so you perform integration by parts again until such time that you can evaluate it freely. Then there are also tables of integrals, but because the calculator is capable of evaluating definite integrals allowed, then I want you to set your calculator in the radian mode, then evaluate this integral. And we will do that here, although for some situations we have to perform integration by parts, we have to evaluate integration by parts. But remember, this is already statics. You're through with integral calculus, so I will just leave this to you as your review of evaluating definite integrals and by applying integration by parts. Although there are problems here where I presented, or I'm going to present, solution by integration by parts. But for this problem, I'll just evaluate this using the calculator. And the value is equal to 23,154 inches to the fourth. Level 36, the area of the narrow strip of uniform width is 750 mm square. Using the fact that the width is small compared with the length of the strip, approximate its moment of inertia about the x-axis. Compare your answer with the erroneous result of multiplying the area by the square of its distance from its centroid to the x-axis. So here is the given figure, and for our solution, let's have a strip which is parallel to this inclined strip. So let's call that the y-axis. This is the x-axis. And because the area is 750 mm square, 750 is equal to 150 times the thickness of this strip. And the thickness of this inclined strip must be 5 mm. 750 mm square divided by 150. So that's why we have 5 mm there. So for our differential area, which is also the dimension should be perpendicular and parallel to this inclined strip, the horizontal projection of the strip is dx, the distance of differential area from the y-axis is x, and the distance of the strip of this differential element rather from the x-axis is y as shown, and that is x. So ix is integral of distance square y square times differential area. So that is our equation. Then we will call the slope or the angle that this strip makes with the horizontal as theta. And the thickness is dx, that's the horizontal projection along x. And this differential area is equal to 5 mm times this inclined value, which is dx divided by cosine theta if we enlarge it here. So enlarging this differential area, remember this is 5 mm, and we'll call the angle slope as theta, which is also the slope here. And because the hypotenuse, or this one, is 150, the vertical is 100 minus 50, so 50. So divisible by 50, 150 over 50 is 3, then 50 over 50 is 1. This is 50, opposite to theta, 100 minus 50, so that means hypotenuse is 3, opposite is 1. 3 is 150 divided by 50, and 1 is 50 mm divided by 50. 100 minus 50 is 50 mm. Therefore, this is square root of 3 square minus 1 square, or square root of 8, 2 square root of 2. This inclined dimension of this differential area would be dx over cosine theta. And since cosine theta from this slope is 2 square root of 2 over 3, so this is dx over 2 square root of 2 over 3, or simplifying, 3 dx over 2 square root of 2. Differential area therefore is 5 times this dimension, 3 dx over 2 square root of 2. So differential ix is y squared, differential ix is y squared, and differential area is 5 times 3 dx over 2 square root of 2. So simplifying, differential ix is 7 y squared times 7.5 dx over square root of 2. Then equating or deriving the equation of this line, or for y. So imagine this right triangle here. This is y minus 50. Y minus 50 were opposite to theta for this imaginary right triangle. As to x, so y minus 50 over x, that's the slope also of this inclined line or side of the strip, equals 1 over 2 square root of 2. So that's why you have 1 over 2 square root of 2. So y equals x over 2 square root of 2 plus 50, or simply uh, that is y, and the variable of integration is x. By the way, when y is 100, x is to be solved, the horizontal projection of this, which is supposed to be square root of 150 square minus 50 square. But since we established this equation, all you have to do is replace y by 100 and solve for x. We can solve for x equal to 141.42, or square root of 150 square minus 50 square. So Ix is 7.5 over square root of 2 integral from 0 to 141.421 of y square. So x over 2 square root of 2 plus 50 quantity square dx. So again, these limits would be from here, 0, to here, 141.421. There are two ways to compute 141.421. It is square root of 150 square minus 50 square, or the other way, you substitute y equals 100 here and solve for x. The value of x is 141.421. Then using your calculator, I will not expand this by binomial expansion theorem. That defeats the purpose of this topic. So because the calculator is also allowed to evaluate this, then in integral calculus, it may be an exercise. So in integral calculus course, this should not be evaluated by using the calculator, but rather we have to expand this. But in this course, because this is already statics, you're supposedly mastered integral calculus, then we'll just use our calculator here. So Ix is equal to 4.375 times 10 to the 6 mm to the fourth. Now for the approximate the erroneous moment of inertia. So the erroneous moment of inertia is equal to the square of its distance from its centroid. So the centroid of this strip is from the x-axis is 50 plus 100 divided by 2, so 75 mm. Then differential area is the area is 750 mm square. So Ix erroneous is equal to 75 square. That's the distance from the x-axis to the centroid of the strip, and the area is 750. So Ix erroneous is equal to 4.219 times 10 to the 6 mm to the fourth. So there is really a difference in value. Level 37, determine expressions for the rectangular and polar moments of inertia Ix, Iy, and Io of the thin strip of area A where T is very small compared with B as shown. So for our solution, this is in relation to level 36. We have a strip there. So for our element, differential element dA, so that's differential element dA, distance from the x-axis is y, from the y-axis is x, and because this is B and B, and Ix, the orientation Ix will be the same as Iy, same orientation because we have B here and B here. So we conclude that Ix equals Iy. So that horizontal projection of this inclined dimension of the strip is dx, and let's call this theta, where theta is 45 degrees because we have B and B here, or the slope is 1 vertical, 1 horizontal. That's also theta. So we have 1 here, 1, and therefore this is square root of 2. So if the thickness, if the horizontal projection of this inclined strip is dx, the vertical projection is also dx because of this 1, 1. So therefore the inclined dimension in terms of dx is square root of dx squared plus dx squared. It is square root of 2 dx as shown. So the differential area therefore is square root of 2 dx times the thickness, which is t. So Ix is equal to, differential Ix is equal to distance square y square differential area. And the differential area is 2 square root of dx times thickness. So differential Ix is y square, 2 square root of 2 dx times thickness. So that's the differential area. So Ix is square root of 2 times thickness, integral from 0 to b, variable of integration is x, 0 to b y squared dx. Then from the figure, by similar triangles, y as to, this is b minus x, because this is b and that is x, so this is b minus x, y as to b minus x equals b as to b, or 1 as to 1. So y as to b minus x equals b over b, so y is b minus x. Substitute here, Ix is square root of 2 times t, integral 0 to b of quantity b minus x squared dx. So if we put u be b minus x, the differential is negative dx. So let's make this negative and put the negative sign before the integral sign. So negative square root of 2t, integral 0 to b of quantity b minus x squared, then negative dx. So take note, this is in the form u squared differential u. And by power formula, so Ix is negative square root of 2 times t b minus x quantity cube over 3 from 0 to b. So if we substitute the upper limit, so this is negative square root of 2t over 3, then b minus b is 0, so 0 cube minus lower limit b cube. So Ix is negative square root of 2t over 3 quantity 0 cube minus b cube. Therefore, Ix is equal to square root of 2tb cubed over 3. Then the area of this strip is equal to the length of the strip, which is b square root of 2 or square root of 2b square root of b squared plus b squared times thickness. So area is b square root of 2 times thickness. Again, the length of the strip is square root of b squared plus b squared, so b square root of 2 times thickness. So let's uh, set up that area from here. Ix is equal to b square root of 2 times b squared over 3. So that's the same. Then we replace this by area, therefore Ix equals area b squared over 3. And because of, we imagine this is the x-axis also, same orientation because the slope is same, 1:1 or 45 degrees, therefore Iy is equal to Ix. It is also ab squared over 3. Then the polar moment of inertia is simply Ix plus Iy. Io is Ix plus Iy, so it is just double this value. So Io is 2/3 AB squared over 3. So that's it, and I hope that you, you were able to follow the explanations, and for the solution of for moment of inertia of strips that are very thin.